Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Arif bin Zamri with metric number E2383069. It's going to present my report on assignment 1 of bauxite deposit. Bauxite is a natural material economically processed to be a high purity alumina, which is a world primary source of aluminium. Aluminium is one of the main components to build an airplane, electronic device, construction materials, and bridges. From the global sedimentary sequence of 1.5 times 10 to the power of 15 tons, bauxite only makes up less than 0.0001% of all sedimentary sequence, which stands around 45 times 10 to the power of 9 tons. It is not deposited. It is an anomaly that represents of what remains after everything else is washed away. It occurs through a process called extreme desilication, which can be divided into three main zones. The top zone, we call enrichment, occurs where aluminium and iron precipitate and concentrate in a residual soil. Then, the second zone of downward flow, or depletion, occurs where groundwater relentlessly leaches mobile elements over 100,000 years. And lastly is the removal in base layer. Soluble elements like sodium, potassium, calcium, and silica are placed in solution and physically flushed out of the drainage system entirely via the groundwater. The four pillars or factors in bauxite ore formation is high temperature and rainfall. This is usually associated in tropical or subtropical climate. Then, it is required to have a high porosity and permeability parent rock to allow a continuous downward flushing shown in the second layer. Then, the tectonic stability requires millions of years of stability to outpace the active erosion, which could result in the destruction of the soil profile. And lastly is the preservation, such as topographic traps and flat plateaus, which is to shelter the remaining residual blanket. The mineralogical composition of bauxite is not a single mineral, but a mixture of three different aluminium hydroxides. The first one, gibbsite, occurs in a low temperature and pressure environment, which is common in a highly weathered lateritic deposit. The second aluminium hydroxide is boehmite. Boehmite occurs in moderate temperature and pressure, which is common in Mediterranean type deposits. And lastly is diaspore. Diaspore occurs in high temperature and pressure, which is often associated in metamorphic environment. Bauxite deposit is divided into two different types. The first one is lateritic bauxite, which is in situ residual processes, accounts for around 85% of global aluminium production. The second type is cast bauxite, which is trapped within a heavily casted topography. This accounts for the 40% of global production. The remaining 1% is designated as autochthonous or transported deposits. The first type, lateritic deposit, occurs in the topographic setting confined to an incredibly old, stable plateau in the warm or tropical regions. The parent rock, often as igneous, metamorphic, or clastic sedimentary, composed of aluminosilicate. Then the process of direct in situ lateralization occurs. The bauxite forms exactly where the parent rock once lay, leaving a massive flat blanket of ore spanning hundreds of square kilometers. The second mechanism or type of karst bauxite occurs in a karst topography defined by the high internal drainage, acidic condition, and dissolved bedrock platforms. The parent rock are often as limestone or dolostone or dolomites are carbonate rocks. The process called autochthonous accumulation and decarbonization took place and leave the trace residues washed into the sinkholes. This accelerate the desilication and finalize the bauxitization. The case study for Wepa Shield showcased the lateritic deposit, which spans an immense 800 kilometers squared on a tertiary land surface. The economic advantage is the minimal overburden that spans less than 1 meter thickness. This is exceptionally thin, making it highly accessible for open pit extraction of the loose pesolite ore around 3.5 meter thickness over the bedrock. The composition is dominantly gibbsitic ore, which form under stable tectonic conditions and a monsoonal climate. Moving on to the global distribution, Australia holds the largest global producer of aluminium because it is dominated by lateritic shield. Guinea also holds the largest unextracted global reserve, while China is a major global aluminium consumer and key producer. Brazil and India also host a massive tropical lateritic deposit, which is vital to the global supply chain. The extraction method in this case involves an open pit excavation, which is often for the shallow open pit mines. The first step involves the open pit excavation of the surrounding ecology, and then the next step is the Bayer process, where the raw ore input is put into a leaching process to provide the alumina output. Next, land rehabilitation involved to protect the ecosystem post-extraction. In conclusion, bauxite is essential and important resource for modern society because it is the primary resource for aluminium. Its formation depends on intense chemical weathering, while mineral composition is controlled by temperature and pressure factor. Bauxite support global development, but sustainability of mining and land rehabilitation are also important for protecting the environment. That's all from me. Thank you for watching.